We're surrounded by all this amazing wireless technology, but have you ever stopped to think about the one invisible trick that makes it all possible? That's what we're going to dive into today, something called frequency mixing. It's happening literally all around us all the time, and we're about to pull back the curtain and see exactly how it works.
Okay, so let's just jump right in with a really simple question. When you talk on your phone, right, your voice goes into the microphone. Can that signal, just your voice, be broadcast directly through the air, like just poof, and it's on its way? What do you think?
Well, the simple answer is nope, not a chance. And figuring out why that is, well, that's really the key to unlocking how basically all of our modern wireless gadgets actually work.
And that leads us to what you could call the wireless transmission problem. See, it turns out that not all signals are born equal. Some of them are just, well, they're not cut out for the long haul.
So that signal, the one that is actually your voice or your data, we call that a baseband signal. It's a low-frequency kind of signal. A good way to think of it is like trying to whisper to a friend across a massive, noisy stadium. It's just not going to work. The signal just doesn't have the oomph to travel very far on its own. It's a total homebody. It needs a ride to get anywhere.
So, if our little signal is a homebody, how in the world do we get it out of the house and across town or even across the globe? Well, this is where our hero steps in. It's called frequency mixing. This is the whole trick, the ingenious process that basically gives our signal a super fast car to ride in. All right, so what is mixing exactly? In a nutshell, it's the process of taking our weak, low-frequency message, our voice, and combining it with a really powerful, high-frequency signal that we call a carrier wave. It's like putting our whispering voice on a giant megaphone. The whole point is to shift our message up to a new, higher frequency that's absolutely perfect for traveling long distances.
You can really think of the whole thing as a super simple four-step recipe. You take your message signal, you take your carrier signal, you pop them both into a special device called a mixer, and boom, out comes a brand new, supercharged, high-frequency signal that's ready to go on its big adventure.
Okay, that sounds almost too easy, right? How does a mixer actually pull that off? Well, this is the really cool part. It all comes down to some surprisingly simple math that honestly feels a lot like magic.
Now, here's the absolute key. Inside that mixer, the two signals are not just added together. That wouldn't work. Instead, it does something very specific. It multiplies them. That's it. That one little mathematical operation is the secret sauce behind this entire process. And when you multiply these two frequencies, something pretty amazing happens. You don't just get one new signal back. You actually get two. You get a sum frequency. That's the carrier frequency plus the message frequency. And you get a difference frequency, the carrier minus the message. So what just happened? You've basically made a copy of your original message and moved it way up into a high-frequency neighborhood where it can ride shotgun with that powerful carrier wave. Okay, theory is great, but let's make this real. How does this actually play out in the real world? We're going to follow a single phone call from your mouth to your friend's ear and watch this whole round trip in action. And what you'll see is that mixing is really just two sides of the same coin. Your phone, the transmitter, uses mixing to shift your voice's frequency up so it can be sent out. We call that up conversion. Then on the other end, your friend's phone, the receiver, does the exact same thing in reverse. It uses mixing to shift the frequency back down to get your original voice back. And, you guessed it, we call that down conversion. So let's just run through that one more time. Your voice becomes a baseband signal. It gets mixed or up-converted and sent out through the antenna. The receiver on the other end grabs it, mixes it again, but this time down-converts it, and voila! Your original voice signal is recovered, ready to be heard. It's a really beautiful, elegant, and symmetrical process. All right, so now we get how it works, but now for the big question. So what? Why does this one little trick matter so much? Well, let me tell you. Its impact it's just massive. It's almost impossible to overstate. I mean, the benefits are huge. It allows for super efficient transmission, which is why we can talk to someone on the other side of the planet. It makes antennas work way, way better. And here's a big one. It's the reason we can have thousands of different channels all running at once. Think of all the radio stations, all the Wi-Fi networks in your building. Mixing keeps them all in their own separate lanes so they don't crash into each other. It's absolutely crucial. Let me put it this way. Without frequency mixing, just forget it. Your cell phone, it's a paperweight. Your Wi-Fi, gone. GPS, nope. Satellite communication, radar systems that keep airplanes safe,
None of it would work. It is, without a doubt, the absolute cornerstone of our entire connected world. You know, this quote here really sums it up perfectly. Mixing isn't just some neat hack or a clever trick. It is a fundamental operation. It's the engine that powers everything else, the thing that enables all these other critical processes and allows our signals to actually travel properly through the air.
So, hey, next time you pick up your phone or hop on a Wi-Fi network, maybe you'll think about that invisible, elegant dance of frequencies that's happening behind the scenes just to make it all work. It really makes you wonder, doesn't it? What other invisible forces are out there quietly shaping the world we live in? Something to think about.